The operators check the process feed tank by comparing the local indications with the indications in the control room. The operators start by comparing the local level indication to the value indicated in the control room. They find that the value on the local indicator is nearly the same as the value that the control room indicator had before it started to indicate no level. However, the control room indicator still indicates no level in the process feed tank. Next, the operators decide to check the positions of the valves associated with the tank and its level indicator. This process tank uses a rotometer to provide level indication. The rotometer uses compressed nitrogen to measure the level in the tank. The valve that isolates the nitrogen supply to the rotometer is found to be in the fully open position. The nitrogen supply lines are checked for any signs of damage. There are no signs of leaks in the nitrogen supply. The outside operator isolates the rotometer from its supply of nitrogen. After completing the isolation, he calls the control room and informs the operator of his actions. At this point, the rotometer is isolated, but the reason why the rotometer was not operating properly has not been determined. To continue troubleshooting, the operators decide to unisolate the rotometer. The outside operator calls the control room operator and informs him of his plans to return the system to normal operation by restarting the pump. The control room operator tells the outside operator that the pump must not be started until the rotometer is operating properly. To find the cause of the problem, the outside operator inspects the rotometer for obvious signs of damage or a problem. When he checks the valve that regulates nitrogen flow to the rotometer, the operator finds that there is too little nitrogen being supplied to the rotometer. This reduced the pressure sensed by the control system, which caused the control system to indicate no level in the tank. The control room operator has the nitrogen bank that supplies nitrogen to the rotometer checked. When this is done, he is told that the tank currently supplying nitrogen is nearly empty. To correct the problem, another nitrogen tank is placed in service. The control room operator sees that the level indication has returned to the value it had before the indication was lost. The control room indication and the local indication are now the same. After receiving permission from their supervisor, the operators restart the transfer of feed material. At this point, the process has been returned to normal service and the troubleshooting is complete. In this troubleshooting exercise, you will make decisions that will take operators through the basic steps of troubleshooting a problem. To complete the exercise, you must identify the problem and its cause, and then correct the problem. The system used in this exercise was created to train operators in process control and in different types of control loops. While the process uses real equipment to create inputs to the control system, actual products are not produced. This allows operators to practice troubleshooting a variety of problems without affecting the operation of an actual process. In this system, liquid feed material is transferred from a feed tank into a distillation column. In the column, the feed material is partially vaporized to separate it into two components, the vapor and the remaining liquid, which are recovered separately. The system consists of a feed tank and its pump, a filter, a heater, a collecting tank and its pump, a distillation column, and control valves that regulate flow to the column and maintain the correct levels in the tanks. Feed material is supplied to the feed tank from another process. The feed material is pumped from the feed tank, through the filter, and the heater into the collecting tank. From the collecting tank, the feed material is pumped into the distillation column. After separation occurs inside the column, the remaining liquid or bottoms product is pumped from the column and sent to another process for further processing. The vapor or overhead product is also removed from the column and sent on for further processing. The control system for this process monitors and controls several process variables, and it positions control valves to ensure that the levels in the feed tank and the collecting tank are properly maintained. The control system also maintains the proper pressure on the outlet of each pump to ensure that the system is not overpressurized. And it maintains the speed of the pump that removes liquid from the bottom of the column. As part of normal operations, feed material is being pumped from the feed tank to the collecting tank. The process variables that the control system monitors and controls are all within their normal ranges. The control room operator monitors the operation of the process on the control system display screens. He is in contact with the outside operator, who periodically checks the local indicators. The control room operator notices that the level in the feed tank has increased slightly and the level in the collecting tank has decreased slightly. The control room operator knows that the control system should be maintaining constant levels in both tanks. If the liquid levels in the tanks change much more, it could be a sign of a problem. A few minutes later, the control room operator finds that the level in the feed tank is even higher and the level in the collecting tank is even lower. The operator now believes that there is a problem and that it must be identified and corrected. To help identify the problem, the control room operator checks the rest of the indicators on the control panel and finds that there is no change in any other variable. The control room operator stops the transfer of feed material by shutting off the pumps. The outside operator calls to inform him that the pumps have shut down and asks why. The control room operator explains that he is troubleshooting a problem. The control room operator again checks the status of the process on the control system display screens and can find nothing wrong. Since he can find nothing wrong, he restarts the transfer of feed material and informs the outside operator of the restart. The operators know that their troubleshooting is not over. The control room operator attempts to increase the speed of the pump, but the pump is already at its maximum speed. The operator knows that the troubleshooting is not over. The control room operator tells the outside operator about the problem. They decide that the best action to take is for the outside operator to check the operation of the pump located between the feed tank and the collecting tank. After checking the pump, the outside operator reports back that all local indications for the pump appear to be at their normal values. At this point, the problem has been identified. The level in the feed tank is higher than it should be, and the level in the collecting tank is lower than it should be. The next step would be to take any action necessary to prevent injuries and system damage. Since the levels in the tanks are not beyond their normal ranges, no preventive actions are necessary. However, the operators know that they must find the cause of the problem quickly. If they don't, the tank levels might become abnormally high or low. Damage might occur, or the process might have to be shut down. Also, if the feed tank level gets too high, there is a possibility of a spill. The operators start to use the process of elimination to determine the cause of the problem. The control room operator decides to use the bracketing method to narrow down the possible causes of the problem. He starts by bracketing the system into 3 parts: the feed tank, the pump, and the collecting tank. The control room operator has the outside operator check the feed tank's level indication system for proper operation. The level indication system appears to be operating properly. After checking the rest of the local indicators at the feed tank and finding nothing wrong, the operators rule out the feed tank as a possible cause of the problem. When the outside operator checks the collecting tank, he finds nothing wrong. The local level indication matches the indication in the control room. So the cause of the problem does not appear to be the collector. The operators now check the transfer pump and its associated controls. The operators start by verifying the operation of the pump. They compare the local discharge pressure indication to the pressure reading on the control panel. The 2 values are the same, so the pump appears to be operating properly. At this point, the operators have eliminated most of the components in the process. Next, the operators check the positions of the control valves. First, they check the valve that controls flow to the collecting tank. They find that the valve is 50% open, which is its desired position. The operators next check the position of the recirculation line control valve. The control system indicates that this valve is shut. However, the outside operator checks a local flow indicator and finds that there is a small amount of flow through the valve. The operators compare the indicated flow through the recirculation line to what the flow should be for the discharge pressure of the pump. They find that the flow is higher than it should be. The control room operator takes manual control of the recirculation valve and attempts to shut the valve. The outside operator monitors the operation of the valve and reports to the control room that nothing happened. The control room operator notices that the level in the feed tank is still too high and the level in the collecting tank is still too low. The operators realize that the system will be difficult to operate with the recirculation line control valve in manual control. So the operator returns the recirculation control valve to automatic operation. When the control room operator tries to return the system to normal operation by speeding up the pump, he finds that the pump is already running at its